Right, so I'm going to tackle the flow/residual network worksheet here. Uh, Hopefully you've already done this on your own, and then you can just verify against what I've done. That's what I would strongly recommend. All right, so question one here is asking me to draw the flow network, and I've been told that the source is vertex 0, and the sink is vertex 5. I think I'm going to draw these a little bit to the left so there's room for stuff. Okay, so this is 0, that's 5. I have edges going from 0 to 1 and 2. So why don't we put those over here? Then I have a 3 and 4. Okay, and so this is just a graph, right, with the source and sink. We also need capacities and flows on each one. So this is 2 out of 2. This is 1 out of 3. 1, 3 is 2 out of 3. 1, 4 is 0 out of 1. 2, 3 is also 0 out of 1. And 2, 4 is maxed out at 1 out of 1. And then I have a 2 out of 2 here and a 1 out of 3 over here. Okay, you should probably take a few seconds to make sure that it's that we're satisfying the flow conservation property. Okay, we're clearly satisfying the capacity constraint here. Right, so that was question one. Question two was to draw the residual network. And so I'm going to do that right next to it here. So the idea here is we copy all of the vertices. So 0, 1, 2, 3, 4, and 5. And then for each pair of vertices, I have to decide whether I have any residual capacity there. So going from 0 to 2, I have a residual capacity of 2 in this direction, but 1 going back. Okay. Up here, it's just 2 going backwards. Over here, it's 2 going backwards. Here, it's 2 going forwards, and 1 going back. Then I have 1 over here, 2 going back. This edge is maxed out in this direction, but I have a 1 going back. And then both of these diagonals are just have a single edge with capacity 1. Okay. So that is question 2, the residual network. And then we're asked to find an augmenting path. And so if I start here, I can't take this edge, but I can certainly come here. From here, I can't go there. I could go back, but that doesn't help. I can come here up to vertex 3, right? And then from vertex 3, I can't go to 5, but I can go back to vertex 1. From 1, I can go to 4. From 4 to 5. So my augmenting path is 0 to 2 to 3, back to 1, and then to 4, and then to 5. So we actually hit all the vertices in the augmenting path. The question that would come up now is how much can we augment the flow by? And for that you have to take the minimum weight on each edge. So this is 2, right? So the weight is 2, the weight here is 1, weight there is 2, and then this is a 1 again, and this is a 2. So you want to take the minimum of these because that's the amount you can push without violating the capacity constraint. So I can push one more unit of flow on this, meaning that I could make this 2, this would become 1, this would drop down to 1, this would also become 1, and this would become 2. And that would be your max flow.